Hello everyone, this is DEEPAK Joshi and today we are going to see another problem statement from LeetCode. As this is the end of the month, generally the POTDs from LeetCodes came to be on a harder side, but this time it is an easy problem statement that says smallest number with all set bits. And now I am out of the prison as well, so I can focus on LeetCode. Uh, in this particular problem statement states that we need to find like the problem statement is smallest number with all set bits. We have given a number n and we need to return the smallest number x greater than or equal to n. So we have to figure out a number. We have to find a number that should be greater than or equal to n, but it should only represent it should only contain set bits. And what are set bits? Set bits are refers to the bit with the binary representation of a number that has a value of 1 only. Like the starting thing can contain 0, like the leftmost parts can contain 0. Let's talk here. Let's say this is a set bit, right? This represents 0. 2 raised to the power 0 is 1. This represents 1, I'm so sorry. This is as well a set bit, that is it represents 3, I would say. And this is also a set bit. I do want to write the numbers, that binary numbers that they represent 1, the decimal numbers that they represent. No, yeah. And this represents 3, and then this number represents, I would say, 7, right? And then there will be another number. I'll just go one more, and this will represent 2 1, then 2 3, then 2 raised to the power 3 is 8, 3 yeah, 8 11, yeah, it will represent 15, right? So if I'm not wrong, I'm just calculating. 2 raised to the power 0 is 1, 2 raised to the power 1 is 2, 1 and 2 is 3, then 2 raised to the power 2 is 4, 7, and then 8, 7, yeah, 15. So I'm absolutely right. Yeah. So there is this constraint, like let's talk about the constraints over here. It says n can vary from 1 to 1000. So I was thinking of 32-bit initially, but the constraint is pretty small, that this n can range from 1 to 1000, and it's a positive number, so that's a very cool thing as well, that it can't be 0 and less than that as well. So like it's an easy thing. So here if I observe the pattern in the decimal terms, I can see that the next number is double plus 1 to the previous number. What does that mean? Like 3 is always equals to 1 into 2 plus 1, and 7 is equals to 3 into 2 plus 1, and then 15 is equals to 7 into 2 plus 1, like some sort of pattern that I'm observing over here. So I was thinking that if we start with a number, let's say I would say, yeah, a number int result is equals to 1. If we'll start with this, right, and I want to iterate till n, till our number or this result is less than n. So while result is less than n, because we have mentioned that equal to or greater than that, that's why I'm writing less than only, hardly greater than or equal to. Yeah. So if that is the case, till then what we need to do is just multiply this result by 2 and add a 1. In that we will always get a set bit, because this is the pattern that we have observed, and then just return the result that we have. So let's see if we thought it right or not. Let's try to run it and then see if that makes sense or not. It says a compilation error. What's that? Error expected. Okay. Oh, I think I ate the closing bracket of the function. Yeah, now it will work. Yeah, it worked. Let's try to submit this and see do we have any another approach or not. Oh, it really worked. Thank you for that. Now we can wait, yeah, where is our description here? So this is one of the approach. The other approach that we can take is one of the pattern that I observe is like let's say we have one. Okay, if we need to get an another set bit, what we need to do is we need to shift it to left. Then it will become like when we say shift it to left, we do something like this, right? So we do a left shift, then it will become 1 0. Okay, and if we take a OR of this number with 1, then like it is 1, it can be written as 0 1, but I'll only write 1. Then it becomes the next set bit, that is 1 1. And if I do the same thing, let's say with the 1 1, I take a left shift, that will be 1 1 0. Take a OR of it with 1, it will become 1 1 1. It's just something to get the next set bit from the number. If we do this, and if we do this till the decimal number is less than n, will break the loop only when the result that we initiated will become greater than or equal to n, because these are the numbers that represent the set bits, very similar to the approach that we did x multiply result multiply by 2 plus 1, but now we are doing the same thing with the bits. So what we'll do is we'll initialize int result equals to 1, the same thing that we do, and we'll make sure that while result is less than n, what we do is result left shift 1 and take a OR of it with 1. That's it. So this will give us the next set bit and return, because as it is an integer, this will store it as integer, and this calculation will be computed in the binary numbers, and overall this comparison is happening in integer. So that's a win-win situation for us, and we'll return just the result. Let's see if this particular use case also works or not. Yeah, I guess it will work. Let's try to submit it, and yeah, it works pretty good. The time complexity for this will be we are doing 2 raised to the power n is something. It will be like log 2 raised to the power n, I would say. Yeah, that will be the time complexity of it. Yeah, I'm not sure on this part. Maybe I'll need to read more on how binary numbers comes up with the time complexity, but yeah, that is the whole flow. And hopefully I was able to explain what are the things that requires that solves these particular problem statement. Yeah, see you in the next video. Let me know if you have any concerns or any questions. Bye bye.